Welcome to Angles and Acid, where we learn things maths and science, and today we are continuing with fractions. Specifically, we're learning about how to add the fractions together. Now, you might think that's very simple, but sometimes not so simple. It requires sometimes an earlier step first. But let's do the simple cases first. Well, the simplest case is when you have two fractions added together, but they share the same denominator. Well, that's easy. A sixth plus 2/6, well, that just gives me 3/6. So that's basically, that's basically the same as 1 plus 2 on the numerator, because they both share the same denominator, and therefore the answer is 3/6. And just as I mentioned in a couple of videos ago where we said simplified fractions, well, I could simplify this. I can actually divide top and bottom by a factor of 3. So I can divide this by 3, I can divide this by 3, and I'll get an answer of a half. Therefore, there's my final answer. That's easy, but life is not always easy for us. Often we get presented with a question where the denominators are not the same. So here I've got to add a fifth and a half, put them together. And here I can actually swap them out for any of their equivalent fractions. So I could swap out the fifth for 2/10, or I could swap out the half for 3/6. Okay, and the trick here is that if I can pick equivalent fractions from both of these sides, if I can make sure they have the same base, the same denominator, then I can actually add them together. And you'll actually see that if I swap the fifth into 2/10 and I swap the half into 5/10, then I can actually smash them together. So this is going to be equivalent to 2/10 plus 5/10. That'll give me 7/10, and there's my final answer, and I cannot simplify that any further because 7 is non-divisible. 7 is the prime. It's a prime number. Okay, what's another way we can go about this? Rather than having to draw out all the possible equivalent fractions, that could waste a lot of time. There's another method, and the other method is to look for the lowest common factor. Okay, now I've seen some of my students, they just want to smash the denominators into each other, and usually you will get a bigger, more complicated looking fraction when you're done, which can be horrendous, or you could be lucky where it's a simple question. But in my experience, it's a bad idea. If possible, try and finish up with the simplest fraction possible, and you will get there by looking for the lowest common factor. The lowest common factor is basically what number can I turn both of these into with a multiplier, such that they're both the same. So can I convert? I can convert 4 into 8, into 12. I can convert it into 16. Okay, and so on. And I convert that 6 into a 12, into an 18, and so on and so on. So what is the smallest value that I can convert both of them into? Can I convert them both into 12s? Yes, I can. So I can actually make a list, okay? So what are the common factors that I can turn them into? I can't turn them into 8s. I can't turn them into 10s. I can't turn them into 16, but I can turn them into 12s. I can do that. I can convert them into 24 and so on and so on. Well, the idea is that once you've made your list in your head, you want to go with the smallest, the lowest common factor. So I want to convert both of these into basically 12ths. So what do I multiply these fractions, top and bottom? So I got to do the same operation, top and bottom, to make sure that 3/4 stays as an equivalent of 3/4. So 4 times what gives me 12? Well, 4 times 3 will give me 12s, and I got to do that same top and bottom. So that makes that fraction there 9/12. For 1/6, well, 6 times what gives me 12? Well, that's 6 times 2 gives me 12. 1 times, and I've got to do the same on the top. Therefore, I'm going to get an answer of 2/12. Now they're the same denominator. Now I can smash them together. I get an answer of 11/12. So that's the other strategy. But again, life is not always easy on us, and so sometimes we might be presented with, well, how do you add a mixed number to an ordinary fraction, sorry, an improper? Well, in this case, this is an improper fraction, but how would you do this problem? Well, first, I've got to convert, I would prefer to convert this into an improper fraction and then smash it together. That's my preference. So let's first do that conversion. Now, if you don't know how to convert a mixed number into an improper fraction, you can go back a few episodes. If not, if I have the time, I'll put a card up here for you. But that's basically what I'm going to be doing right now. 4 times 2 plus 1 all over 2. And I still have the rest of my question, 5 over 3. 4 times 2 is 8 plus 1 is 9. 9 over 2 plus 5 over 3. Can I add them together? No, because the denominators for both of those fractions are different. So then I go looking for the lowest common factor that I can convert both of them into. Well, can I convert both of them into 4? No. Can I convert them both into 6? Yes, I can. So let's go with that. So 2 times 3 will give me 6. Going to do the same top and bottom. And 3 times 2 will give me 6. I'm going to do the same thing, top and bottom, to make it an equivalent fraction. So 9 times 3 will give me, no. 9 times 3 is 27. And 6 plus 10 over 6. So that gives me 37 over 6. Sorry, I was just double checking my 9 times tables there. So there's how you do it. So for when you get presented with mixed numbers, you may need to convert that first before you can then start trying to convert them using the lowest common factor. Before I leave you in this video, I want to give you something to work on. And so here you go. Try and add these two mixed numbers together and write them in the comments down below, and I'll give you a heart to the first person who presents that answer in the comments down below. And I'll catch you guys in the next video. See you later. Bye.